You know, when you think about those giant, high-tech warehouses, the name of the game is always more, right? More speed, more efficiency, more robots. But what if, and this is a big what if adding more robots actually makes things worse? Well, today we're going to dive into a really fascinating case study that asks that exact question. How many robots are just too many? And yeah, this is exactly where the theory just smacks right into reality. I mean, on paper, it's simple. More robots equals more work done faster. But in the real world, well, you end up with this, a high-tech traffic jam. This is a story about those hidden and honestly, pretty surprising complexities that come with automation. All right, so to really get how we end up in a robot gridlock, we get to meet the main character of our story. It's called the Automated Guided Vehicle, or AGV for short. And you've probably seen these things whizzing around in videos without even realizing what they are. They are the absolute workhorses of modern logistics. So what is an AGV, really? Just think of it like a self-driving cart. Its whole job is just to get something from point A to point B. That's it, no questions asked. And get this tech has actually been around since 1954. Crazy, right? They're kind of like the quiet, super reliable foundation of any modern factory floor. And as you can see here, AGVs are definitely not a one-size-fits-all kind of deal. I mean, you've got everything from these little nimble carts that just tow stuff around, all the way up to these massive haulers that can literally carry the weight of a blue whale. It really is like its own little highway system, with all these different vehicles designed for very specific jobs. Okay, so now that we've met our AGVs, let's jump into a real-world example. There was this company, right? They were building a brand new factory, had 9 different workstations, and they needed a super efficient way to move materials between all of them. The obvious answer, AGVs, of course. But that's where the real challenge kicked in. So the engineers, they had to solve this puzzle. What's the perfect number of AGVs? You know, it's a classic problem. If you have too few, you create a bottleneck, and everything grinds to a halt. But if you have too many, you're just burning money on these expensive robots that are just sitting there doing nothing. So the engineers did what engineers do best. They crunched the numbers. They looked at all the travel times, the workloads, the distances, the whole shebang. And their first calculation came back with a really clear answer. 2. Just 2 AGVs should be enough to handle all 640 material moves they needed every single day. Easy peasy, right? Case closed. Well, not so fast. There was a tiny problem. See that calculation? It assumed a perfect world, a world where these robots never, ever get in each other's way. And the engineers knew that was just not realistic at all. What was really going to happen when these 2 robots had to share the same paths, the same intersections? To get a much more realistic answer, they turned to this really cool tool called a digital twin. Basically, it's a computer simulation of the entire factory floor. It's like a video game version of their warehouse, where they could test out different scenarios and see how the system would actually behave in the real world, all without having to buy a single physical robot. Pretty smart. So they set up an experiment. They ran 2 different simulations to compare. First, the one with their calculated 2 AGVs, and then another one with 3. Now, sure, a 3 AGV system is going to cost more upfront, but they were hoping it would be faster. The big questions were, would it be worth that extra cost? Or would it just create a whole new set of problems? So they let these simulations run for a full 16-hour workday, collecting data on absolutely everything. And what they found, well, it was really, really surprising. Okay, so check this out. With 2 AGVs, the system looked good in some ways. The robots were almost always busy, which is good, and there was hardly any congestion. But the delivery times were a complete disaster. The average was almost 10 minutes, and get this, one delivery took a whopping 81 minutes. So that initial calculation, the one that didn't account for robots bumping into each other, yeah, it was clearly way off. So the answer seems obvious, right? Just add another robot. With 3 AGVs, they can share the workload, and those terrible delivery times should get way better. But as we're about to find out, it is not nearly that simple. See, in a complex system like a factory floor, every single change creates a ripple effect. And in this case, adding that 3rd robot, well, it created a totally new, completely unexpected problem. All right, now look at this. Adding that third AGV had a huge impact on performance. The average move time plummeted from 9.4 minutes all the way down to just 3.1 minutes. The whole system was way more responsive. You'd think mission accomplished, right? But, and this is a big but, there was a trade-off. With 3 AGVs, the congestion shot up fivefold. It went from just 2.3% to almost 12%. So yeah, the robots were faster, but they were also getting in each other's way a lot more often. And this is that classic congestion problem we were talking about. The very thing they did to fix the speed issue created a brand new traffic issue. The factory floor literally became a robot traffic jam. So let's just break down this trade-off step by step. You add more robots, right? That means they're more available to grab new jobs. So your response time gets way faster, which is great. But that also means more traffic on the floor, which leads to, you guessed it, higher congestion, with robots spending more time just waiting for each other to pass. It's a super delicate balancing act. So what did they do in the end? Well, the company decided to go with the 3 AGV system. That increased congestion, but that was a price they were willing to pay to get that huge improvement in delivery times. I mean, an 81-minute delay, that's a total deal breaker, but an 11% traffic jam, yeah, they could live with that. And I think the crucial point here is pretty clear. In any kind of complex system, just throwing more resources at a problem isn't always the simple solution. It's really about understanding the entire system, seeing the whole picture, and finding the right balance. And that's exactly why tools like simulation are just so incredibly valuable. You know, this whole case study is just a perfect little example of the kinds of challenges we're going to face more and more as we keep automating our world. It's not just about building better, faster robots anymore. It's about designing smarter systems. So the big question we're left with is this. As automation solves all our old problems, how do we get better at predicting and solving the brand new ones that it creates?